In this chapter, we're going to talk about radical expressions and equations. Not so much equations, but at least radical expressions. This is the opposite of powers. So the power of something is like x squared has a power of 2, x cubed has a power of 3, and so on. And this is kind of the opposite of that. Those exponents, say you're multiplying together something 3 times. Well, with radicals, we're finding out the thing that I would have to multiply together a whole bunch of times to get where I want to be. Okay, so radicals and radical expressions. So let me talk about that a little bit more explicitly. So x squared is x times x, right? And x cubed is x times x times x. So if this number, this exponent, counts how many x's are multiplied together, then that's also true for fractional exponents. So like x to the 1/2, that's half of an x multiplied together, which would mean that I would need x squared, x to the 1/2 times x to the 1/2. There's half of an x there, and there's half an x there, so together I have a full x. That's an x to the first. So the analog for the third is similar. I would need 3 of the x to the 1/3. I only have a third of them in either spot, so I need 3 of them together to give me 1x multiplied together. Okay, this is where you see now we've got square roots and cube roots. Those are the exact same thing. The square root of a number, this is the value that we need to multiply together twice by itself, right, to get to x. So I get the square root of x times the square root of x equals x. Cube root is similar. Cube root, I need 3 of them together. I don't want an equals there, I want an arrow. And this would equal x, right? So if I take 3 cube roots together, I get x. If I take 2 square roots together, I get x. So the idea that exponents of fractional nature and radicals are the same thing is very, very easily seen here, right? So x to the 1/2 is half of a factor of x. Well, that's the same thing as the square root of x, because I need 2 of these to multiply to be a full value of x. I need 2 of these to multiply to be a full value of x. X to the 1/3, that's the cube root of x, and so on. So x to the 1/5, that's the 5th root of x. I would need 5 of these multiplied together to give me 1 full x. I would need 5 of these together to get an exponent of 1 on the x. Okay, it works for not just 1 factors too, right? So let's look at like x to the 2/3. That's 2/3 of a factor of x. So this is, it's the cube root of x squared, because it's 2 times as big as a third, right? So if I put 2 of these guys together, I'm 2/3 of the way there to getting to a full x. Here, if I put 3 of these guys together, I would get to like x cubed, or sorry, x squared. So the cube root of x squared times the cube root of x squared times the cube root of x squared, that's equal to x squared. Well, that's also equal to x to the 2/3 times x to the 2/3 times x to the 2/3. I've got 3 of the 2/3, so if I add my exponents together, I get x to the 6/3, which is also known as x squared, right? So these fractional exponents, the denominator in the exponent tells you which root you are taking, and the numerator in the exponent tells me like how many of those roots I have together. So if it's like 2/3, it's the third root, and I've got 2 of the x's under that third root. Okay, all our normal exponent rules apply. The exponent rule with addition, as you saw, right? I've got 2/3 plus 2/3 plus 2/3. That applies. The exponent rule, so of powers, so x to the 2/3 cubed, that's equal to x to the 2/3 times 3, right? That's the power rule for exponents. All our old exponent rules still apply. We just have to deal with fractions when we're counting the fractions. Okay, that's a quick introduction to rational expressions. In the next video, we'll talk about actually evaluating some things and seeing some graphs of the basic radical expressions.